So one of the biggest questions I always get is, how do you know which equation to use? So this is in a worksheet that I made up just to go through how do you decide which equation to use. So there's a few equations that you are given. This is the first one. It's that velocity is equal to acceleration times time plus your starting velocity. The second equation is this one. Its position is equal to 1/2 times your acceleration times time squared plus your starting velocity times time plus your starting position. And lastly, we have velocity squared is equal to your starting velocity squared plus 2 times acceleration times your change in position, or final minus initial position. All right, so how do you know which one of these to use? Well, what you're going to do is you're going to start by figuring out what information you have in the problem and what you're trying to figure out. And you're going to use that to decide which equation you want to use. So in terms of the letters that go into these equations, it is oftentimes helpful to look at what the vocabulary words are, definition for them, what their units and variables are. So when we talk about displacement is how far something went. That's going to be looking at the change in position. So that's where it went compared to where it started. So that would be like your ending position minus your starting position. So final minus initial. The units are going to be in meters. So that's M. Position is just where something is. So that's X. Usually that's your final position, or after so many seconds, you could ask, oh, after 12 seconds, where is it? That would be X. Starting position is where you started. That's also measured in meters. So now we have 3 things that are all measured in meters. Velocity is how fast it is going. And starting velocity is how fast it was going at the beginning. So think about those little zeros here as like at time 0, what was the velocity? And when you read it, it's read v naught. Acceleration is how quickly the velocity increases or decreases, so either speeding up or slowing down. And then for time, this is how long it takes, so that's usually measured in some number of seconds. So how much time? All right, so now that you have those variables and units, so a car starts moving forwards up a hill at 12 meters per second. As it goes up the hill, it has a uniform backwards acceleration of 1.6 meters per second squared. All right, so we're going to go through this. It says a car starts by moving forward up a hill at 12 meters per second. So that's going to be my starting velocity because it starts moving at 12 meters per second, and those units match over here. So that's my velocity. So I'm going to write a little v naught. So this is my starting velocity. As it goes up the hill, it has a uniform backwards acceleration of 1.6. Okay, so one word to pay attention to is backwards, and we were originally going forwards. So that means that this is my acceleration, and specifically acceleration is going to be equal to negative 1.6 meters per second squared because it is the opposite direction as your motion. So if we say that it's positive 12 for my starting velocity, then acceleration is negative. All right, so what is its displacement after 6 seconds? So I'm looking for something with displacement. That means I'm going to be looking at my change in position. So I need something that has an x or a delta x in it. And then I'm going to need something probably with time because this is time. And so this 6 seconds is time. All right, so what I'm going to do is I'm going to now figure out which equation I'm going to use. So If I'm trying to find displacement, I need to have something with an x. So if I look at my three equations right here, this one has x in it, this one has starting and ending x in it. So either of the second or the third equation would work. This first one is not going to cut it because it doesn't have an x in it. And then I'm going to go through and I'm going to figure out what information I have in this problem and then kind of check it off. And if I don't have something, then I can't use that equation. All right, so do I have acceleration? Yes, I have acceleration right here. So acceleration is fine for both of those. Time, yes, I have time. I want to know at 6 seconds what's happening, so I have time. Okay. I know my starting velocity is 12. So, all right, I have that. Starting velocity is 12. And then do I have my ending velocity? Nope, I do not. All right, so because I do not have my ending velocity, this is not going to work because I don't have this and I'm trying to figure out my position. And I know I'm not given my starting position, but I'm going to say that my starting position is 0 meters because if I want to know my displacement, I want to know how far I went. Well, the easiest way to measure something is to start at 0. So when you're using a ruler, you don't use the middle of it. You start at the end with a 0 on it and then go from there. And so we're going to do exactly the same thing, but we're going to say we started at a position of 0. All right, so our next step is to go ahead and rewrite this equation. So we're going to rewrite it. X is equal to 1/2 times my acceleration times time squared plus my starting velocity times time plus my starting position. And now we're going to go ahead and plug in all the numbers we know from the problem. All right, so my acceleration was negative 1.6, so I'm going to go ahead and plug that in. So acceleration, negative 1.6, and I'm going to put this in parentheses because I don't want to get confused about that negative. And I'm going to put all the other stuff in here. All right. Time, we know that it's 6 seconds because that was given here in the problem. So 6 squared times 6. X is what we're trying to figure out here, so I'm going to leave that as X. Starting velocity was 12, so we're going to start with 12. So our starting velocity. And then our starting position, we decided to go ahead and make that 0, so that'll be 0. And then all we need to do is plug this into our handy dandy calculator. Now, if you got 100.8, that means that you missed this negative on that acceleration. So don't miss that negative. Otherwise, you should get an answer of 43.2 meters. Now, part B asks you to do the exact same thing, but now we're going to figure out how far it went after a different number of seconds. Now we're going to find our displacement after 9 seconds. So all I need to do is use the same equation all over again, but instead of using 6 seconds, I need to use 9. So I'm going to go ahead and rewrite it. All right, so for part B, I get exactly the same distance. Now, this is weird because it doesn't really make sense until you realize that whatever this was, a cart or a car, it was rolling up the hill. And after a little bit, it's going to come rolling back down the hill. So it's going to go up and slow down. And then at a certain point, it's going to start going backwards. And so somewhere between 6 seconds and 9 seconds, it was going uphill and now it's going downhill. And it just so happens that at 6 seconds and at 9 seconds, it is exactly, perfectly in the same spot as it was at 6 seconds. So how much time will it take before it stops? Now my hint here is what is the velocity when it stops? All right, I'm going to scroll down and we're going to kind of clear this up a little bit. So if I want to know how much time it will take, that means that I need to make sure that my equation has time in it. So this one has time, that bottom one does not have time, but this one does have time. All right, my hint is what is the velocity when it stops? Well, velocity is going to be 0 when it stops. And that's going to be at the end. So that's my final velocity. And so I need my final velocity to be 0. So this middle equation is not going to work because I do not have velocity and I'm trying to solve for time. So that equation isn't going to cut it. And so the bottom equation is not going to work because I'm trying to solve for time and it doesn't have time in it. So that's gone too. So that leaves me this first equation. So that's this velocity is equal to acceleration times time plus my starting velocity. And so I look at the problem and I'm going to make sure I have everything. All right, velocity, that was the velocity at the end. So that's 0. And then is equal to acceleration. Remember that my acceleration here was negative 1.6 because if I said forwards was positive, then backwards is going to be negative. So this is negative 1.6 times time. We don't know that. So we're going to put a t. Please do not put an x. Please use the variable for what it is that you're actually solving for, or I may mark it wrong. Not because I'm trying to be mean, but because I may not understand what you're saying. And then my starting velocity is that 12 meters per second. So we're going to plus 12 meters per second. And then I just need to solve. All right, so I'm going to subtract 12 from both sides. That's going to give me negative 12 is equal to negative 1.6 times time. And then I'm going to go ahead and divide both sides by negative 1.6. And that gives us 7.5 seconds. Now, 7.5 seconds actually makes perfect sense because at 6 seconds and at 9 seconds, it was in exactly the same spot. And so halfway between those is 7.5. If you have questions, let me know. Otherwise, I'm going to do a second video for number 2.